Hello everyone. In this session, we'll learn Docker from the ground up. We'll just start by understanding the real problem and why was it created and what problem it solves. Then we'll see what Docker is, how containers work, and why Docker has become core technology in the modern software and DevOps. This is very beginner friendly and we're just focusing on concepts and not commands. By the end, you should be clearly understanding what Docker does and where it fits in your learning path. Let's start with a very common problem in the software development. A developer builds an application on their laptop and it works perfectly there. But what if that same application is deployed on a server or cloud and it fails? This is usually because of environments that are different, and it might be because of different operating systems or different library versions or missing dependencies or incorrect configurations. This is where the famous line comes from: it works on my machine. So Docker was created to solve this exact problem by making environments consistent. So Docker is a containerization platform. Containerization means packing an application together with everything it needs to run. So inside a Docker container, we include the application code, the runtime required, and the libraries, and even the configuration. So all these bundled into an isolated unit, and it is called as a container. So because everything is packed together, the application behaves the same way everywhere. Either it might be in your own laptop, it might be in your server or cloud. The environment remains consistent. To understand Docker better, we need to compare containers with virtual machines. What is a virtual machine? A virtual machine runs a full operating system on top of another operating system. This makes the virtual machine heavy and it will take some time to start. But Docker containers are built different. They share the host's operating system kernel instead of running their own OS. This makes the container lightweight and fast. As a result, you can run as many as containers on the same machine, while a few virtual machines would fit. There are three Docker components you must understand. First is the Docker file. What is a Docker file? It is a text file that contains instructions on how to build an image. And second is the Docker image. An image is a read-only blueprint created from the Docker file. And third is the Docker container. A container is a running instance of an image. In simple terms, Docker file creates an image and the image runs as a container. So Docker follows a simple workflow, that is build, ship and run. In the build stage, Docker reads the Docker file and creates an image. In the ship stage, this image is stored in a container registry or shared with others. In the run stage, the same image is started as a container on any system. This workflow ensures that the application runs same everywhere without manual setup or configuration steps. Docker plays a central role in DevOps workflows. In a typical pipeline, developers push code to a repository. A CI pipeline builds a Docker image automatically. Then that image is deployed into testing or production environments. Docker makes automation easier, supports microservice architecture, and enables faster and more reliable deployments. It is also important to understand what Docker is not. So Docker is not a virtual machine. It does not run entire operating system inside each container. Docker is not Kubernetes. Docker runs containers, but Kubernetes manages and orchestrates the containers. Docker is not also a complete security boundary. Containers provide isolation, but they are not as isolated as virtual machines. Docker is essential knowledge for modern software roles. So if you are a developer, Docker helps you avoid environment issues. If you are moving into DevOps or SRE roles, Docker is a foundation skill. Docker is usually learned before Kubernetes and cloud orchestration tools because understanding Docker makes it advanced, cloud native technologies much easier to grasp. To summarize, Docker solves one fundamental problem, that is environment inconsistency. You build the application once, package it with its dependencies, and run it anywhere without changes. That is Docker's core promise: build once, run anywhere.